Welcome back, everybody. Today we're going to talk about lesson 7-2. We're going to get into graphing quadratics, but first a little warm-up. It says on the graph, or graphically on the graph, find and circle the x-intercepts. Remember another word for x-intercepts? The zeros, where it has a height of 0. So let's look at 3 first because the graph's already there for us. So this is an x-intercept because it's crossing the x-axis. And this is an x-intercept. So 0 and -4. Those are your zeros or your x-intercepts. Now, from the equation, we can find that by using our calculator. All right, so we're going to go to our calculator. We're going to type that equation in. Just go to y equals. All right, it says y equals. There's the button you hit, and then put in whatever comes after the equal sign. So we have x squared minus 7x minus 18. Let's take a look at the graph. Looks like it's hitting at -2 and 9. Remember, you can look in the table too. 9 makes it 0, and -2 makes it 0. So you can find it that way. So let's sketch it. It is a parabola. Looks something like that. It's hitting at -2 and 9. Those are your zeros or your x-intercepts. And just sketch that picture. All right, those help us with factoring too, remember, from way back the beginning of the year. They'll come back into play a little bit. All right, next one. Go ahead and put that into your calculator. Y equals 2x squared minus 8. So again, go to y equals 2x squared minus 8. So it looks like -2 and 2. And again, if you want to be sure, go to the table. -2 makes it 0 and 2 makes it 0. So again, I'm just going to sketch that quick. -2 and 2. All right, and all of these are parabolas, all right? So we're going to get into graphing them today. Now, keep in mind, you can always use your graphing calculator. I'm going to show you some tricks, though, for some of it to find the middle or your turning point. So we're going to learn a new formula today, and it's the formula to find the axis of symmetry. Now, remember, if we're looking at a graph, let's say we have a parabola like this. All right, so let's say this is where we fold it in half right here. That would be the line x equals 3. Okay, that's what the axis of symmetry is. Not the best picture, I know. To find it algebraically, you're going to use this formula. And I'll show you, you can always use your graphing calculator too. X equals, right, because it's going to be x equals a number, -b over 2a. X equals -b over 2a. That's the formula for axis of symmetry. Definitely want to know that. Now you might say, well, where do those letters come from? Think back to your standard form. Y equals ax squared plus bx plus c. That's standard form. The number in front of x squared is your a. The number in front of x is your b. So that's where those two letters are going to come from. If you can find that, that's going to be the center of your table because that's where it turns. All right, so that would be this point right here. So we're going to make a table, and we're going to put the axis of symmetry in the middle of the x values because it is x equals. And then we're going to go to our calculator, and sometimes you can skip right to this step and not have to worry about the formula. This step's the most important step. But sometimes you can't find the axis of symmetry looking at the calculator, so it's important to know this formula. All right, then we're going to make a table of values for the y values. We're going to plot points and connect them, and then we're going to add arrows in the label. All right. So first of all, why don't we type this into the calculator? Because you're going to have to anyways. So anytime you see f of x equals or y equals or anything like that, we're going to go right to the calculator. 2x squared plus 4x plus 6. Now, before I even look at it, do you see how the number in front of x squared is negative? That tells me that it's going to be a graph that looks like a frown. Okay, so my end behavior I know is going to be concave down, like a frown, because x squared's being negative. If someone's being negative, they're frowning. All right, so again, I want to look at my table first and look at my graph. So if I hit graph, you can see it's a frown, it's concave down. All right, but you can also tell by looking there. All right, so if I look at my table, there's a really neat thing that happens with quadratics. You're going to have to scroll up or down, but you want to see where the y's start to repeat. So if I go up a little, and do you notice how the top and bottom of my table, negative 42, negative 24, negative 10, 8, 8, 6, 6, and then, or no, I'm sorry, that was 0, 0, 6, 6, and then 8's in the middle? That right there is our turning point. All right, so x equals 1 is actually my axis of symmetry. But let's just practice calculating it. We're going to do lots of practice here. X equals negative b over 2a. Now go back up here. Our a is negative 2. Our b is positive 4. And our c, which we don't need for this, but it's important to know, is positive 6. So if I'm plugging these in instead of negative b, I'm going to do negative 4, because that's what b is. Over 2 times a, 2 times negative 2. So I have negative 4 divided by negative 4 is positive 1. So my axis of symmetry is x equals 1. Now I know that's complicated, so you're not always going to have to do that. That's just one way to find the middle of your table. So I put that, since it's x equals 1, right in the middle of the table. I personally, though, I like to just go to the calculator and I find the middle. I see that 1/8 is my turning point. See how everything else has a match? It's just that 1/8's in the middle. That's your vertex. So now I'm going to plot the points above and below it that I can fit. Now my graph goes to 10. So I'm going to do negative 2 all the way down to 4. So we got 3 above and 3 below. So if you look, we have at negative 2, it's negative 10. At negative 1, it's 0. At 0, it's 6. 1/8, which we already have. 2, 6. 3, 0. 4, negative 10. All right, so if you look at this table, there's a lot going on here. Right here is your vertex. That's your turning point. Everything else has a match. See, 6, 6, 0, 0, negative 10, negative 10. That point in the middle is your vertex, okay? So it says graph the parabola using the table. All right, so negative 2, negative 10. And remember, you can look at the graph in your calculator to make sure you're doing it correctly. That's what it's going to look like. So negative 2, negative 10 is down here. So I'm going to go back 2, down 10. Negative 1, 0, back 1, staying at the x-axis. You can see it doesn't hit there, so you shouldn't have a point right here. It should be right there. All right, 0, 6. So I don't go from side to side, just up 6. That's hitting the y-axis, so that's going to be your y-intercept. All right, 1, 8, over 1, up 8. And that's your vertex. That's the very top of your graph. Now it's going to turn and go back down. 2, 6, over 2, up 6. 3, 0, over 3, not going up or down. And then 4, negative 10, over 4, down 10. All right, now we're going to carefully connect the dots. I do want to point out it's a nice rounded graph, the parabola. Yours should be as well. So I know it's tough, but just carefully try to connect the dots, especially on the Chromebook. It's kind of tough. All right, there's our graph. We're going to extend it and put the arrows and label it y equals negative 2x squared plus 4x plus 6. Okay. Now, a couple things I want to point out to you. Here's your vertex. 1, 8 up top here. We graphed it over here as well. That's your vertex. And it's at the top of the graph, so it's a max. There is no min because it goes on forever. So the very top of the graph is 8. All right. And again, that's your vertex. It's the 0.18. It's right here, your vertex. Okay. Now, the axis of symmetry, we use the equation, but if you were to draw a line right down the center of your graph, this line would make it so you could fold the graph in half. If you folded the graph in half on that line, it would match up perfectly. So this is your axis of symmetry. It's x equals. It's not y equals because it's never going to cross the y-axis. Look, it's running parallel with it. It's x equals, and where's it hitting the x-axis? At 1, which is the same thing you found by using your formula. Okay, so let's answer some questions. Your vertex is 1, 8. It's also right here. Your vertex, if you want to label, you can. But again, it's the 0.18. It's a point, so make sure you've got your parentheses around it. All right, your domain, remember that's your x's being used. This graph's going to get wider and wider and wider as it goes. You're always going to use all the x's. So your domain is all real numbers, and you can use just a capital R, or you could say all real numbers, or you could say it goes from negative infinity to positive infinity for your x's. Your y's are a different story, though. Your y's are your range. Remember, that's your height. Your y values that are being used, look at your y values go way down into the negatives, but they only go up to 8. Your y's are never going to be 9 or 10 or 11. Your y's are all 8 or below. So your range, all of your y's are less than or equal to 8. Okay? Your roots are your zeros. Remember, that's another name for your x-intercepts. Where is it hitting the x-axis? Right here, -1 and 3. And your y-intercept, that's easy. Where does it hit the y-axis? Right here at 6. Okay, so get used to using those parts. You're going to need to know how to find each of those. All right, let's look at this next one. Actually, let's see where we're at with time. I might split this up into 2 videos. Yeah. All right, so if you want, you can go ahead and try this next one, but I'm going to make a separate video to walk you through this. It'll be short, but it's important that you practice with this. If you get stuck, stop by and see me at the Math Lab. Have a great day.